Why is the induction machine the most renowned AC motor? Let's explore its secrets and why it's so widely used. Induction motors are often found in compressors, pumps, circular saws, machine tools, or other common applications. Their popularity is due to their ease of commissioning and robust mechanical characteristics. A robust mechanical characteristic means the motor's speed stays nearly constant when under load, i.e. producing torque. We name mechanical characteristic because these parameters are purely mechanical: speed and torque. Why is it called an induction machine? As an AC machine, it operates on the principle of electromagnetic induction. If you haven't seen our video about different types of electrical machines, check it out on our channel. Unlike synchronous motors, which are mainly used as generators or actuators, induction motors are predominantly used as motors because they are straightforward to operate. Just connect an induction motor to an AC supply, and it will start working. But how does it work? Understanding the operation of an induction motor is key. All electrical machines work based on the electromagnetic induction law, meaning they function without physical contact. Induction motors have two main components: the stator and the rotor. Typically, the rotor is the moving part and the stator is fixed, but there are exceptions, depending on applications. These components are made from copper and iron, separated by an essential air gap. Without this gap, the rotor wouldn't rotate. On the stator, you'll see slots where copper windings are placed, and the armature is made of iron. The rotor also has slots, and there are two types of rotor construction for induction motors: one with windings and one where aluminum or copper is cast. Now imagine the rotor with windings. If you are familiar with transformers, you will see that they are similar. The difference is that a motor produces mechanical power by rotating a shaft, while a transformer produces electrical power. The stator of an induction motor has windings supplied with AC current, just like the primary winding of a transformer. Inside, the rotor also has windings, acting like the transformer's secondary winding. When AC current flows through a wire, it creates a magnetic field around it, acting like a virtual pole with polarity that changes over time. This changing field induces a back electromotive force, EMF, in the rotor. Therefore, if the stator has a current flowing through its windings producing a magnetic field, the rotor's windings will induce a back EMF. However, that's not all. To generate a current that produces a magnetic field in the rotor, similar to the stator, we need a closed circuit. This results in a magnetic field in the rotor, creating virtual poles. Consequently, the machine has poles on both the stator and the rotor that continuously move, creating motion. Picture it like this. A man sits on a donkey, holding a stick with a carrot tied to the end. The man represents the stator, and the donkey represents the rotor. The donkey tries to catch the carrot but never succeeds, always chasing it. This is analogous to how the induction motor works, with the poles on the stator and rotor continuously moving, creating motion. For the poles to chase each other, you need a virtual pole on the stator's, for example, south, and an opposite pole on the rotor's north. Lenz's law tells us, the induced current always opposes the cause that produced it. The current produces a magnetic field, creating virtual poles that always oppose the stator's poles, keeping the rotor in motion. The second type of induction motor rotor is the squirrel cage rotor, where usually aluminum is cast into the slots, forming bars. These bars are short-circuited with aluminum rings, allowing current to flow, creating a magnetic field and virtual poles. Advantage of AC over DC: if you apply DC current, you'll get a constant magnetic field with unchanging poles. An advantage of induction motors is the natural changing polarity of the poles. That's why in DC machine we need collector, or they have to be controlled electronically. This is just the first part about induction motors. Stay tuned for episode 2 from season 1. Thank you for watching. If you found this video helpful, please like and subscribe to support our channel. Your support helps us create more content,